let's just say we want to get rid of this for now. So we're going to pass, what do we need? Well, we need the, basically in this case, the row, column, and then this is the player number. So we need all those things. So we need row, column, and then I kind of want to put player first. So player like that. So now these parameters, in order to run this function, we have to pass these parameters. So if I just comment these two things out and we try to run this, it's going to get angry with us because we didn't actually pass any of the required parameters. Let me just, So this is the actual error it throws, and it says, hey, game board is missing 3 of the required positional arguments, and it even tells us, hey, you got to pass these things. And if we just pass one of the things, like we'll pass a 1 here, we're still missing 2 more. We're missing row and column because it goes in order. So the next thing you might be aware of is to pass a value for player, we really could just pass 1. And then let's say we want to play on row 2, column 0. We can pass things like this, 1, 2, and 0. So I could run this, and everything works. Obviously, we didn't play a specific place yet because we haven't handled for that. But we're able to run the function by passing them like this. But later on, like right now, game board is right underneath our functions definition. So it's pretty legible because we can always just glance up here. But in long code, that's not going to be legible, right? So if you're passing hard values like that, that's going to be pretty hard. But what if your variable name is literally, current player, and then row choice, call choice, right? In that case, if you've named your variables pretty good names, you definitely still don't need any more information. Anybody reading this code is like, oh, okay, I know it's being passed. But in our case, what if we don't, because we are just kind of hard coding them? How can we handle for that? Well, you can also just say player equals 1, row equals 2, and then column equals 0. We could run that again. Everything worked. The other thing you can do is you can mix it up. So you could, for example, you could say just 1 here, row 2, column 0. That's totally fine. And then the other thing we can do is add defaults to the game board. So we could default to 0, row can default to 0, and column can default to 0. So we might want to do this just so that this function could be run, and just like if we just want to see the game board, we could run that and everything's fine, right? So now let's add our logic for actually marking up this game board. So what we'll do is right here, we will just say, let's just say game, and then row, and then column. So these values, these variables here, are just whatever value is passed through those parameters. We can just say that equals whatever the player was passed. And this is why 000 is going to work just fine. It's just going to set everything to 0, at least for now. Because later, if we've actually played here, and if a player actually has a position on the game board, we're going to set that position as 0, and that's not going to be very good. But for now, it works just fine. And then later, if we were to say game board, let's just run it again. And then we're going to play player equals 1, row equals 2, column equals 1, or something like that. We can see, okay, yeah, it's been marked there. So the only other thing I might say here is maybe if we said, we definitely want to have some sort of handling for how do we want to actually display the game if we didn't pass anything here. So, and the other thing to note is, let's see. So what we could say here is just if player does not equal 0 or something like that. Whoops. And then just tab this over. Then play it this way. You also could have a little flag that might even make more sense, just display. And just display could equal false to start. And then instead you could say if If not, just display, just display equals false. So then you could say here, just display equals true. In this case, if we scroll up, we get just the purely display, and we didn't set 0, 0 equals 0. Because again, if let's say someone had actually played at that 0, 0 mark, we would be in trouble, right? So now, if just display is equal to true, so if not just display, so if just display, we're not going to actually run this code, and then otherwise, no matter what happens, we want to print out the game board. So I think that's a decent place for us to stop. But I want to start talking about, what about this game board being defined outside of our function, and then we're using our function to modify the game board. Right now, that's working, and everything's fine. We're not running into any problems doing that. But as long as you continue down this path of doing things that way, like modifying a function, or modifying a thing that's outside of your function, you're going to find some weird things start happening. And if you don't learn either how to properly do it every time correctly, or how to just kind of do it by habit and just always get the thing that you want, later on down the road, you're going to be pulling your hair out trying to figure out why your programming isn't doing what you know it should be doing, but yet at the same time, you know programming is infinitely logical, and you're making a mistake somewhere, and it just is driving you nuts. So in the next tutorial, we're going to be talking about the concepts of mutability and immutability, which we've already somewhat talked about, but this is kind of a different variation on that topic. So anyways, that's what we're going to be doing in the next tutorial. A quick shout out to my most recent sponsors. I'm going to have a really hard time with some of these names. As I comment these two things out and we try to run this, yeah. So this is the actual error it throws, and it says, hey, we're missing passing them like this. But later on, like right now, game board is right underneath our functions definition. So it's pretty legible because we can always just like glance up here. But player, and then if we don't, because we are, other thing you can do is you can mix it up. So you could, for example, you could say just one here, row 2, column 0. That's totally that. Equals here, or just whatever value is equals here, and then row, and then column. So these values, these variables here, are just whatever value is passed through those parameters. We can just say that equals whatever the player was passed. And this is why 0, 0, 0 is going to work just fine. It's just going to set everything to 0, at least for now. Because later, if we've actually played here, and if a player actually has a position on the game board, we're going to set that position to 0, and that's not going to be very good. But for now, it works just fine. And then later, if we were to say game board, let's just run it again. And then we're going to play player equals 1, row equals 2, column equals 1, or something like that. We can see, okay, yeah, it's been marked there. So the only other thing I might say here is maybe if we said, like, we definitely want to have some sort of handling for how do we want to actually display the game if we didn't pass anything here. So, and the other thing to note is, like, let's see. So what we could say here is just if player does not equal 0 or something like that. Whoops. And then just tab this over. Then play it this way. You also could have like a little flag like that might even make more sense, like just display. And just display could equal false to start. And then instead you could say if not, just display, just display equals false. So then you could say here, just display equals true. In this case, if we scroll up, we get just the purely display, and we didn't set 0, 0 equals 0. Because again, if let's say someone had actually played at that 0, 0 mark, we would be in trouble, right? So now, if just display is equal to true, so if not just display, so if just display, we're not going to actually run this code. And then otherwise, no matter what happens, we want to print out the game board. So I think that's a decent place for us to stop. But I want to start talking about, what about this game board being defined outside of our function? And then we're using our function to modify the game board. Right now, that's working and everything's fine. We're not running into any problems doing that. What's going on, everybody, and welcome to part 8 of our Python 3 Basics tutorial series. In this video, what we're going to be talking about is kind of revisiting the concept of mutability. Because I think it's pretty important that we don't get through the Basics series using the methodology that we're using and not address mutability. I'm not sure if that logically made sense, that string there. But basically, the way that we're doing things right now is we're modifying this game variable outside of this function here. We're able to do that because it's mutable, but this can be very tricky at times, and later on, if you continue to code with the assumption that that's going to work out for you, eventually you're going to hit a wall, and it's not going to feel good, and you're not going to understand like why you're hitting this wall. And it's like the most frustrating thing in the world when you believe, you're like rereading your code, you're like, I've done this a million times, why isn't this working? This is logical, this is so simple, and you're gonna just be pulling out your hair. So I think I would be doing a pretty big disservice if I didn't at least bring it up, because it's probably not gonna come up again. And arguably, I don't think this has ever come up in any tutorial. I've never really addressed this, but it can bite you. So let's talk about it. So sometimes you might see, so like if you want to modify a value outside of a function, if it's a list of lists, we can at least do one thing, and that is set a value. Remember that. Set a value in that list of lists. Okay? We're getting away with that. We can do that. But that's not the case for everything that we could plausibly be working with. So what I'm going to do is, I think for now, what I'd like to do is I'm going to comment this out, and then we're going to show some examples, and then I'm going to show you what I think would be a superior method of kind of building these kinds of things. So first of all, I'll just comment those out in multi-line comment, make some space, and in fact, what I'll do is I'm going to copy all of this. I'm just going to copy that, come up here, paste, and then we're going to run gameboard just display true for now. And in fact, actually, we can just run gameboard because it won't matter for the purposes here. And let's run that. Okay, so that works, right? Now, I guess I am going to make the change that I wanted to make. But basically, we want this function to eventually return gameboard. But gameboard is printing, so maybe what I'd like to do is let's print. Man, this is challenging because I want to show an exact change. That's okay. So anyways, gameboard, we print gameboard and we can see no change has been made. And then if we were to run player 1, row 1, column 1, and what if we can print game here, and then after running gameboard we can print game again. So we'll have like 3 games basically. And we can see initially, okay, and then here's the pretty modified version, and then here is after the function has run. Yet again, a version where that 1 is indeed modified in there. Now what I'd like to do is change this. So we're going to change first the variable here of game, and we're going to make it, instead of string, I want to play a game. And now what I'd like to do is take game board. We're going to get rid of all of the parameters. But none of these parameters were important. We weren't like passing, we were never passing game into here anyways. These were just going to be used later. And in fact, we actually could leave these here because we're not even going to use them. And that's fine, we can leave them there. And instead what I'm going to do is I'm just going to remove this code here. And all I want to do now is change game to be a game. Now, knowing what you know, what's going to happen when we run game board? And just to keep things clean, I'm going to remove that just so it's a little simpler. But you're probably expecting game to end being called a game. Let's go ahead and run it though. And we can see here, no, that's not true. What if we print game here? Because a moment ago we were somehow able to access the game, but now we're unable to access game early on. So immediately we know something is afoot. And let me run this again. And then, but then what if we print game after we've set a game? Okay, so we're thinking everything's good at this point, and then we get down here and we're back to I want to play a game. That's because this string is immutable. We can't go and change that. So this can start to kind of run you into some trouble later on. So like, what if we were to do this? So what if we said print? And one thing we can do is we can always check the unique ID of an element in Python using the built-in function ID. So we'll check the ID of game here, and then we can check the ID of game here. And then maybe at the very end again. So start thinking about, okay, what do you think, which IDs are going to be the same? Do you think this and this ID will be the same, or this and this ID, or all three will be different, and so on? Okay, so we can see here, the first ID, let's say, ends in 152. The next ID ends in 376. What about, oh, I'm sorry, the first one, sorry guys. The first one ends in 376. The next one ends in 152. And then finally it ends in 376. So basically, from the beginning, this function never actually modified the value of game in the beginning. And that's a pretty big deal. So, so let's go back to playing with lists then, shall we? So let's do, we'll print game. I don't want to print the IDs anymore for now, I don't think. And in fact, let me just comment that out, because we'll come back to printing the ID of game, but right now I just don't really want them. So paste that into there. And I'm going to get rid of that one. Actually, we should leave it. I'll comment that out. So then what if we change game to be now a list? 1, 2, and 3. And then game, what if now we just try, what if we try to call game a list at this point? What happens? We got 1, 2, 3. We change it to be a game, or so we thought, right? Wasn't this supposed to be mutable? We were just seeing examples of it being mutable moments ago, right? Now we've got game equals a game. We print, oh, we never ran. Let's run game board. Game board, there we go. Okay, we run here, we do print game here, and sure enough it says a game, but still, at the end, we get 1, 2, 3. So it still didn't get modified, despite us thinking, wait a second, wasn't this, moments ago, a list of lists seemed to be mutable, right? Well, what about game 1 equals 99? Now what happens? Now we see, oh, we have modified the initial one now. Because, again, here, if we were to print, let's print the IDs, we'll see that they changed IDs. But if we just simply, oh no, okay, good. I thought we were going to get in trouble there. Wow, I'm definitely hitting Y and it's not going in my favor. Okay. Anyways, game 1 equals 99. Run that again. Let's see, what have we done wrong here? Print game. Hold on. Why are you still... See, I feel like it's still defying me, and this time it shouldn't be defying this way. Are we not running... Okay, we're not running game board. I see. Game board. I'm confusing myself. I'm like, wait a second. Okay, so printing out game again, we can see here it does indeed modify it. So what are we able to do? We're able to modify, right? We're able to modify that object. So we can change the value of that object. But can we change the object itself? No. Okay, so that can get us into some serious trouble down the line. Now the last thing I want to do, and last time I tried to do this we got into trouble. Let's see if I can get away with it. I'm trying to get back to I want to play a game. Cool. And we stay with I want to play a game. One more thing for me to show you guys is we can actually global game. And so if we say, global, oh my gosh, global game, what this does is it sets game to be a globally accessible and manipulatable. Anyways, it sets it to be a global value that we can start modifying from within this function. It's going to affect that variable name globally. So the way that's going to work is we will be able to modify game now. So for example, if we run this, we've globaled game we're not passing game board. Of course, I continue to run into that, and I keep trying to run it, and I'm like, wait, it's not doing what I said it was going to do. Okay, now, it has been modified to be a game, and it gets a new ID and all that, and then if we were to print game down below here, print ID of game, we see that it retains the new game value that it got from the game function. But at the same time, even though that has happened, it also has modified this initial, it literally changed that variable up above. Okay, so a lot of stuff to unpack there for sure. I also have passed, in the text-based version of this tutorial, I put in a little quiz, and that Daniel, or Danos from the Discord, wrote up. And I think it's actually a pretty good quiz. So if you want, I'll have the link to the text-based version of this tutorial in the description. Go there and copy and paste this code into some script or something, and beside all the X's or on a sheet of paper or whatever, say, okay, here's what I think X is going to be equal to, right? And then run it and see how you did. Even after 7 years of Python, I still missed one of them. It was, I don't really want to talk about it necessarily, but it was this one here. And at least I think it was the, I want to say it was the middle one. Yeah, okay. It was that one. And, maybe for you guys, or people that are following along that have nothing to do with the basics, maybe you missed nothing on this test. But my argument is, if you missed anything on this little quiz, or you had to think kind of hard about it, chances are when you're zooming through writing a program, that's how I program, by the way, you are highly likely to make the mistake. So the whole point of this tutorial has been, one, to draw your attention to how you can run yourself amok with mutability, but also I would argue we should go ahead and just pass game here, or maybe better put, let's call it game map, or apparently game board. Where did that go? Oh, that's the name of the function. Let's not do that. So we'll call it game map. So we pass game map. I would argue let's go ahead and call this game map. So we're going to modify this temporary game map variable here. Game map, enumerate game map. And then when we're all done, return game map. Now again, in this exact problem, in this exact code, this is not really doing anything special for you, but unless you can write perfect code or take that quiz and get it right every time and always never make that mistake, I'm just going to argue that maybe you want to get in the habit of doing things this way, or you want to check it every time. But in general, this is the way I would just write everything. It may not be necessary to do it in all cases, but I would do that. And honestly, I went through a good probably 4 or 5 years of Python before I realized there was a thing going on there. And I just always wrote code this way, and you know what? It never got me in trouble. So anyway, just going to share that. I know, I'm confident some people are going to disagree with that methodology, and if you do disagree, that's all right. Write it however you want to write it. But in this case, if we're going to say game map and then return game map, we will always want to say something like this: game equals game board, and then game equals game board when you want to play. And let me just run that real quick. Okay, what's our error? This is zoomed in way too much for me. Type error, missing one. Oh, we're not, okay, we didn't pass the actual game map. Okay, so game, and then we pass game. Okay, and now everything acts in the exact same way. So the idea here is you pass the game map or whatever object you're attempting to manipulate with your function. You pass it. You modify that temporary, parameter value or variable, and then you return it when you're done. And then, when you're using it, you say the thing that you're attempting to modify equals the result of that thing, and you pass that thing and all that. So In terms of efficiency, I haven't run it, so if you were looking to scale a program to like, millions of connections at a specific time, this may not be the best way to do that, but a lot of code isn't like that. So, and this is really just a basics tutorial, but I would take that into consideration in terms of how you should be doing it. And obviously, if the thing is immutable, we can't do it like with a string or something like that, then you will have to treat it this way. But if you have something like this where we're just trying to modify a certain value in a list of lists, no, it's not required. But if you go through your programming tutorial thinking you can do everything this way, you're going to quickly find out, no. You may not do it that way. So anyways, pretty long tutorial on that, but it needed to be covered. Like I said, definitely check out the quiz that's in the text-based version of the tutorial. It's just kind of a good little quick test to see if you understand it. And if you don't, come to the help channel in the discord.gg/Sentex, and somebody there will be happy to explain something if you are confused. And finally, a quick shout out to my most recent awesome channel members. We've got Fluff, Bill, Michael Newham, and Ace Ryder. Thank you guys very much for your support. It allows me to do videos just like this one, so I really appreciate it. I hope everybody has enjoyed, and I will see you in the next video. What is going on, everybody? Welcome to part 9 of the Python 3 basics tutorial series. In this video, what we're going to be doing is coming back to our tic-tac-toe game, coming back to reality, and addressing the fact that when you write a program, you have the best intentions, but whenever you start letting users play tic-tac-toe game, coming back. What is going on, everybody? Welcome to part 9. edition of the Python 3 Basics tutorial series. In this video, what we're going to be doing is coming back to our tic-tac-toe game, coming back to reality, and addressing the fact that when you write a program, you have the best intentions, but whenever you start letting users play with your program or other programmers use your program and kind of build on top of it, different people think in different ways, and people start trying to use your program in ways you didn't intend or didn't think of, and things start to go wrong. And then with the users, sometimes your users are just stupid, or they're trying to do something, or they don't understand, or you didn't explain it well enough for them to use what you've created the way you intended, or whatever. Or people just try to break your stuff. All these reasons mean we should try to handle for errors. Most of the time, like an example would be like when you go to someone's website and you try to visit a URL that doesn't exist, you usually get some sort of decently looking, 404 page that says, hey, this page doesn't exist, go back home, something like that. Well, if the programmer doesn't specifically handle for that 404, you are going to get a very disgusting, like black and white, just 404, and it's going to look pretty darn bad. And it's going to discourage people from staying on your website. And in fact, most of the time if someone gets that, they're going to bounce off of your website. The same thing is true with your app. If your app just crashes, people have very little patience. So let's talk about error handling. So probably the biggest error that's going to happen is somebody's going to try to play tic-tac-toe, and gosh darn it, they don't like the idea that we started with 0. They want to play on row 3, dang it. So they're going to do that, right? And again, right now we're kind of hard coding things, but later we're going to ask the user, where do you want to play? They're going to input where they want to play. So let's say they input a 3, and we run it, and oh, it looks so ugly. It looks so ugly. Now, in Sublime Text, this is what we see. And basically we're looking for the what's called title cased, where the letter of every word is capitalized. So in this case, the title is, or the error, the title cased error is index error. And officially it's actually at the end of the error. So we've been running everything in Sublime Text, and maybe now would be a good moment for us to address running things from the console. The other way you would actually run a program is probably not in your editor. So let's go ahead and open up console. So on, at least on Linux, you can right-click and open console here or open terminal here. On Windows, you can just come up to the address bar up there and just type CMD, and that'll open up a terminal right where we are. And Control Plus is not a valid. Let's see, properties. Let's see if I can do this quickly. Let's go 28. Okay, good enough. So now let's say we want to run tutorial 9. So the way we would do that is, one, you could type just Python, and currently that is referencing Python 3.7 for me. But if you have multiple versions of Python, by the way, quit is a built-in function, and you can exit. That's just like by default now, I just type it. You could also kind of build on top of it. Different people think in different ways, and people start trying to use your program in ways you didn't intend or didn't think of, and things start to go wrong. And then with the users, sometimes your users are just stupid, or they're trying to do something, or they don't understand, or you didn't explain it well enough for them to use what you've created the way you intended, or whatever. Or people just try to break your stuff. All these reasons mean we should try to handle for errors. Most of the time, like an example would be like when you go to someone's website and you try to visit a URL that doesn't exist, you usually get some sort of decently looking, 404 page that says, hey, this page doesn't exist, go back home, something like that. Well, if the programmer doesn't specifically handle for that 404, you are going to get a very disgusting, like black and white, just 404, and it's going to look pretty darn bad. And it's going to discourage people from staying on your website. And in fact, most of the time if someone gets that, they're going to bounce off of your website. The same thing is true with your app. If your app just crashes, people have very little patience. So let's talk about error handling. So probably the biggest error that's going to happen is somebody's going to try to play tic-tac-toe, and gosh darn it, they don't like the idea that we started with 0. They want to play on row 3, dang it. So they're going to do that, right? And again, right now we're kind of hard coding things, but later we're going to ask the user, where do you want to play? They're going to input where they want to play. So let's say they input a 3, and we run it, and oh, it looks so ugly. It looks so ugly. Now, in Sublime Text, this is what we see. And basically we're looking for the what's called title case, where the letter of every word is capitalized. So in this case, the title is, or the error, the title case error is index error. And officially it's actually at the end of the error. So we've been running everything in Sublime Text. And maybe now would be a good moment for us to address running things from the console. The other way you would actually run a program is probably not in your editor. So let's go ahead and open up console. So on, at least on Linux, you can right-click and open console here or open terminal here. On Windows, you can just come up to the address bar up there and just type CMD, and that'll open up a terminal right where we are. And Control plus is not a valid. Let's see, properties. Let's see if I can do this quickly. Let's go 28. Okay, good enough. So now let's say we want to run tutorial 9. So the way we would do that is, one, you could type just Python, and currently that is referencing Python 3.7 for me. But if you have multiple versions of Python, by the way, quit is a built-in function, and you can exit. That's just like by default now. I just type it. You can also do you should be able to get away with maybe Control. No, you can't get out with Control C. So, anyways. What do we do if we want to actually run a Python program? Well, if you want to specify, you could say pi-3.7. If I hit enter here, it still opens up the same version I'm on. So we could say Python 3.7, and then what do we want to run? So I think it was we're on tutorial 9. So we'll run tutorial 9, and we'll actually see this is the full traceback. It doesn't have that extra stuff that we saw in Sublime Text. But basically, this is the error, and then it gives us a little snippet of code that it saw. It tells us in what file did we see it. In most cases, when you get an error like this, the real error that you're looking for is at the bottom of your script. If you're working in a much larger project, though, sometimes it can get buried because the traceback literally traces back the error and goes in the order that the program ran. So sometimes at the end of your code or at the end of the traceback, it does have an error. But the thing that caused that error is sometimes buried deep because it was a different script that errored, and then the errors continued through until we got to the current place that you're working. So sometimes it won't be at the very, very bottom. But this is always what you're looking for. You're just looking for that. But it will always give you the file name, and then on what line here it starts with where it occurred, but then here it also gives you line 9, specifically where did it happen. So on line 16, we made the call to modify here. So at first, it says line 16, that's where that happened, but then specifically on line 9, we threw the index error. And if you ever get an error and you have no idea what it means, Google. It's your best friend. Just go to google.com. I probably could have just typed it right there. Index out of range means, and gosh, it's been searched so many times that there's even a thing up here. Sometimes you'll need to add Python to the end of what you're looking for, but it's the same result in this case. Or maybe if you're using like a package and you've got some sort of really crazy looking error, you could add like package that you're using with Python. And by package, I mean like some sort of third-party library. Like TensorFlow is a machine learning library, stuff like that. Anyway, for now I'm going to close out of here. I'm going to close out of here, and we're going to continue along. I just wanted to show you that normally you won't see all of this. This is because I'm using Sublime. Okay, so let's talk about how do we handle for this error. I just want to clean up that stuff. I don't know how to make it go away while I'm busy working. So how can we handle for this error? Well, we know it, first of all, we can kind of, I can predict this error is going to happen. Eventually, someone's going to have fat fingers. They're going to accidentally input, rather than a number, maybe they hit a letter, or maybe they hit a number too big, or maybe they're just curious to see what happens, okay? It's going to happen. It's just inevitable with this type of program. So we already knew it was coming, but how can we just generally handle for it? Well, there is a try and except statement that we can use. So we can say except, and then we'll just say, well, we'll just print something went wrong. Okay, so then I'll change row to 3 again, run it, and then it says something went wrong. So at least this time we handled for it. We didn't do anything about it, but we handled for it. And what we could do is just ask that user to do, input again, try again. Something went wrong, try again, basically. But this isn't very helpful necessarily to your user or to a programmer who's actually working with your code and is like, okay, thanks. That's not helpful to me, right? So we can take it a step further, and remember, it was an index error, a title case index error. So we can actually say accept index error as E. Something went wrong. Well, we could say, something like this. We could say, I'm trying to think of exactly how I want to word it. I would say, error. Did you input row column between 0 as 0, 1, or 2? That's probably the way I would do it. And then I might comma E after that, so we're just throwing in the actual error here. So we could run that again, and then now the error is error. Did you input a row column as 0, 1, or 2? And then, or maybe make sure you input. So maybe make sure you input. Otherwise, this sounds like that's the mistake you made. And then we'll just print out the error there. Something like that. Okay, so this isn't actually a program I'm going to distribute. So, so I guess I am actually distributing this program. Anyways, we can make this better, but you get the idea. Now we've handled very specifically for an index error. The only place I can see an index error happening in this code is here or here. And the only reason I could imagine is somebody entered something that was not a 0, 1, or 2. Okay, cool. So we've got that handled for, but what if, darn it, what if a programmer is using this and, they done goofed and they pass game board or something like that into that function? We run, oh gosh, it's ugly, it's horrible, oh gosh. Okay, so how can we handle for that? I mean, as a programmer, I'm expecting, my fellow programmers to be smart enough to not make this mistake. But what if they make it? So we could generally handle for it. I'm not sure I would. We might actually want this to throw a pretty hard error. But let's say we wanted to handle for that kind of an error as well. So let's say you've got a program that you just want to run indefinitely. So an example of this is like a web parser. So I've got a spider that crawls the web to parse news documents to generate sentiment on. Anyways, I want that running all the time. I never want it to crash. So I encase all of the code in many versions of exception handling because I want to catch every exception, including ones I didn't even think about, and I want the code to continue to run. So how can we do that? Well, we can just add another exception. So here we could say accept an index error, print that. Otherwise, we can also just accept, and this is just a general exception as E, print something. Whoops. Something went very wrong. And then E. Great. Okay, now we could run this. And what happened? Oh, we didn't pass. Okay, so try again. Boom. Okay, something went very wrong. Function object is not scriptable. Okay, that makes a lot of sense. And we've handled for that error. Again, you might not actually want to handle for that specific type of error. You might not want things to proceed if someone made that error. You might actually want it to break, and in which case you could force it to break. The next thing, and the only other thing I want to bring up, is that in try and except there are two more statements we could pass. You can have try, except, you can have else, and then you can also have finally. So these are two statements that you'll pretty rarely see, but especially like with finally, you will see this run at the very end. Like if you're trying to maintain a connection or something in like some sort of I/O operation where if you were to disconnect randomly midstream, it could cause a mess, you would use finally to kind of clean up the mess before the script closes out or something. But just know those exist. If you want to learn more about them, again, you've got a friend, and his name is Google.com. There are tons of tutorials on it. I have some try except else finally tutorials. You could search them on YouTube or whatever. Just know those exist, and I hate to talk about try and except and not mention, hey, by the way, but they're very rare. I handled for that error. Function E, print, something, whoops, something went very wrong. And then E. Great. Okay, now we could run this. And what happened? Oh, we didn't pass. Okay, so try again. Boom. Okay, something went very wrong. Function object is not scriptable. Okay, that makes a lot of sense. And we've handled for that error. Again, you might not actually want to handle for that specific type of error. You might not want things to proceed if someone made that error. You might actually want it to break, and in which case you could force it to break. The next thing, and the only other thing I want to bring up, is that in try and except there are two more statements we could pass, and then the error, so and if number, maybe they hit a left. So we could say except, and then we'll just say, we'll just print, something went wrong. Okay, so then I'll change row to 3 again, run it. And then it says something went wrong. So at least this time we handled for it. We didn't do anything about it, but we handled for it. And what we could do is just ask at this point, ask that user to do, input again, try again. Something went wrong, try again, basically. But this isn't very helpful necessarily to your user or to a programmer who's actually working with your code and is like, okay, thanks. That's not helpful to me, right? So we can take it a step further, and remember it was an index error, a title case index error. So we can actually say accept index error as E, something went wrong. Well, we could say, something like this. We could say, I'm trying to think of exactly how I want to word it. I would say error. Did you input row column between 0 as 0, 1, or 2? That's probably the way I would do it. And then I might comma E after that, so we're just throwing in the actual error here. So we could run that again, and then now the error is error. Did you input a row column as 0, 1, or 2? And then or maybe make sure you input. So maybe as a programmer, I'm expecting, versions of, boom. Okay, something went very wrong. Function object is not scriptable. Okay, that makes a lot of sense. And we've handled for that error. Again, you might not actually want to handle for that specific type of error. You might not want things to proceed if someone made that error. You might actually want it to break, and in which case you could force it to break. The next thing, and the only other thing I want to bring up, is that in try and except there are two more statements we could pass. You can have try, except, you can have else, and then you can also have finally. So these are two statements that you'll pretty rarely see, but especially with finally, you will see this run at the very end. If you're trying to maintain a connection or something in some sort of I/O operation where if you were to disconnect randomly midstream, it could cause a mess, you would use finally to kind of clean up the mess before the script closes out or something. But just know those exist. If you want to learn more about them, again, you got a friend, and his name It's google.com. There are tons of tutorials on it. I have some try except else finally tutorials. You could search them on YouTube or whatever. Just know those exist. And I hate to talk about try and accept and not mention, hey, by the way, but they're very rare. I rarely see people actually using them. So just know they exist. Okay, so at this point, okay, we've got some basic error handling. You can also cause certain errors, which we can talk about later. But to throw an error, you can also do the following. So we can, here, you can use raise. And this will raise a certain type of exception, and you can raise a very specific one. So there will be times, or there could be times, where you want to purposely do that. Anyway, so that's it for error handling. We just wanted to have at least some basic error handling for the doofuses. That tutorial, we are ready to start determining who won the game. For if someone tries to play. How do we know when this entire row is 1s or 2s? Or how do we know when vertically these are all 1s or 2s? Or diagonally this way, or this mediocre game of tic-tac-toe. So, what's going on, everybody? Welcome to part 10 of the Python 3 basic series. We have been working on our game of tic-tac-toe up to this point, and in this video we are going to be determining whether or not we've got a winner, or at least one of the versions. So, but syntax, we haven't even done user input yet. I understand. That's really going to be like the last thing that we add. So if you're wondering when that's coming, or if it's coming, it's definitely coming. It's going to be a full game of tic-tac-toe, I promise. But really, to test all this stuff, it would be really tedious to like enter in all the little inputs along the way. So we're really just going to kind of hard code the game and do testing, and then at the very end, we'll add in actually, giving user input. So in order to validate whether or not we've got a winner of the game of tic-tac-toe, there's really, 3, maybe 4 ways to win the game of tic-tac-toe. 4 via programming, 3 if you're just explaining it to a friend. So the first way is you could win horizontally, as player number 1 has done here, right? This row. You can also win vertically. So if this is all the same, or these are all the same, or these are all the same, you won. The other way is diagonally. So that's if these 3 are the same, or these 3 are the same. Okay? That's how you win. Now, just like the other things, these are clearly subtasks. So determining winner breaks down into three like subtasks of programming. Like basically, it's going to take 3 different algorithms to determine, is there anyone that won horizontally, anyone vertically, anyone diagonally. And arguably diagonally, depending on which way you calculate it, might take actually two different algorithms. Ding, time to code. Okay, so let's handle for horizontally. So how might we handle horizontally? Well, I can think of like a few different methods. Like one way we could do that is by, we could go row by row, and then maybe for each element in that row, like we could set like some sort of flag, and then what we could say is like for each element in that row, if that element equals row, maybe, row and then index 0. If all of those equal row index 0, then congratulations, you've done what you intended to do. Now, if that's not true, then no one won. But that's going to get like really messy, really quickly, not really going to be the most ideal way for us to do that. So the next way a programmer might come up with doing this would be something like this. So let's say define when we're going to pass current game, because we've decided that's the way we're going to do it. And then we're going to do like something like this, like for row in game. And then we could say, we could print the row. But then we're going to say, call 1 equals row 0. And then we're going to do the same thing for 2 and 3. So call 2, call 3, 1, 2. And then at the very end, well, really in each for loop, not really at the very end, if call 1 equals call 2 equals call 3. Hot diggity, we got ourselves a winner. Okay, cool. So, win. And then game is what we called it, right? Game, yeah. So, run it. Boom. We got ourselves a winner. Congratulations, player number 1. Now, what's the problem with this, though? So, let's say let's say we actually write this code, and then we write this code for like all of our, you could do this for all the verticals. You could do it. Surprised that happened again. Thank you, Nora. I'm not really sure how to pronounce that, but thank you for your support. Anyways, back to what we were doing. So with, we can do it this way, but what happens when your boss comes to you and says, "Hey, Johnny, we really like what you did with the 3x3 tic-tac-toe. Make it a 4x4 now." And then you're like, "Dang it!" And then you're like, "Okay, but that's okay. That's okay. I will just go into my code and change this." Super simple, right? But then what happens when your boss comes back and don't forget, you've done this now for however you decided to calculate vertical and diagonal. And then your boss comes back and they're like, "Hey, Johnny, can we make the game size of tic-tac-toe dynamic?" And at this point, you are going to have a pretty big problem because you've hard-coded this. So then you might be thinking, well, I can't do dynamic, but what I can do is I could have a separate tic-tac-toe game for each size of tic-tac-toe. Like I have a 3x3 version, I could have a 4x4 and a 5x5 and all that. Like I could just have a separate script. And that's not good. That's what I would describe as disgusting. Okay? But through my career of doing contracting consulting for various companies, I've seen people do that. I've seen people have 1,000 or more variations of a script that is otherwise identical except for like one variable change. Don't do that. That's called technical debt. And you do not want it. Like the first time you program something like that, okay, I guess maybe you'll get away with it, but then over time as things change or you need to make minor changes, suddenly you need to write a Python program to make the changes. So this isn't ideal. So we know, because we've talked about repetition and stuff, we know this is probably not right. Then we are thinking, okay, well what if we do that initial idea where it's like, we iterate over the rows and then maybe not match flag could be like false. And then, whoops, so a not match flag is false, and then for item in row, we could say if item equals row 0, if item equals, I'm already confusing myself now. If item, how about if item does not equal row 0, not match equals false. No, not match equals, this is so hard, equals true. Okay, then, not match equals false, not match equals true. So, if, if not, oh man, this was really poorly written. Print winner. What have I done wrong? I thought that was going to get away with that. Call 1, not defined. Where's, oh, it was down here for some reason. Okay. Okay, apparently they're all winners. This isn't even what I wanted to spend my time doing, but for row in-game, how about all match equals true for item in row if all match equals false if all match print winner. That's probably a little better, but again, we're still having like this whole equals. What are you talking about? If item or item in row print item, and then row 0 if item, so 111 should be a winner, but here this definitely should not be a winner. All match if item Oh, double equals false. Come on, man. Okay, try again, idiot. Okay, so here we have, this is the basic series, by the way. Okay, so this, it was that stupid double equals. Still tagging me after 7 years. Okay, so this works, right? And this is dynamic enough. Like, we could make this larger. The problem is, that's a lot of code for that. Like, arguably we don't need this. That was just for debugging purposes. But we needed all that. So what can we do instead, right? So I'm going to let you guys in on a pretty big secret of programmers. And I probably shouldn't be sharing it with you, but I'm going to share it with you. And it is called Google.com. So this is how anybody writes JavaScript, I'm pretty sure. Okay. So anyways, any downvotes on this video, I know you are a JavaScript programmer. So anyway, so how can we use Google to our advantage? One thing we can do is check if all items in list are same. And we're using Python. Well, it guessed Python for us, so fine. Okay, cool. We did a search because we didn't know how to do this. So rather than going to Stack Overflow and posting our own question or joining a Discord and asking such a Googleable question, we just Googled it, right? That was really simple. Okay, so let's check the first answer. Awesome. So, okay, this person has really broken it down. I feel like the title says enough. Performance, he would not like to incur any unnecessary overhead. Okay, so that's a lot of information for a simple question. Okay, we've got a good deal of information here. Some pretty confusing looking code, to be honest. Some sort of, this looks like maybe a, yeah, I guess. So at some point, you could use like a generator or something. So rather than iterating over every single element, as soon as you find one element that doesn't match, you could immediately stop iterating. You don't have to waste any further time. Okay, we've got some tables. Dude, this is such a simple question. And man, these people are going all out. Okay, so here we have a really simple answer to the simple question. I do appreciate some of this stuff. I can't believe there's like tables of time. Like, who built this? This is hilarious. But anyways, yeah, so we got a great answer. Not only that, I mean, there is an abundance of information to what I would describe as an unbelievably simple question. It was asked 8 years ago, and honestly, the answer today looks to be pretty good. There may be like some sort of method nowadays. If there is, I don't know it. And like I said before, you don't actually always need the special method to do these things. But anyway, this looks pretty good. X.count, okay. And we just see, okay, is the count of the first element, so we count how many occurrences of the, the element in the 0th position, how many occurrences are there, and then we see, is that the same number as the length of that list? If so, that means all of them are the same. So, 6 times faster than the set solution. Interesting. So, I don't really know how .count works, but it surely would have to iterate over every item in the list. But anyways, that's simple enough. I think everybody watching this can understand that one. Also, it's one line of code. So, rather than this nonsense, we could just do boop and then replace X with row. Row and row. Okay, then we ask if this print winner. Run it, and there we have our winner. Now, one more thing we need to address is at the start of the game, everything is zeros. So like, what if I do this? Right now, there are no winners, but if we run this, it's going to say winner, right? So we need one more final check, and that is, and row 0 does not equal 0. Easy enough. Let's run that one more time. and we see that no, there is no winner because the one row that did have everything equal, well, that had zeros and that's no good. Okay, so a lot of information there, some silly mistakes on my behalf, but that's okay. I'm going to go ahead and leave those in there. I think it's good, especially on a basics tutorial, to kind of go over the confusing bits, but I think that's it. So, if you guys got questions, comments, concerns, whatever, feel free to leave them below. And aside from our sponsor in the video, I appreciate the most recent other channel sponsors, Luis Fernando, I can't say the Macedo, I don't know, Reginald Roberts, that's a good sounding name, Ratish Nair, Akros, and Matanoia? I don't know. That's a challenging one. I'm not sure how you pronounce the OIA bit. Comment below if you see this. I'm curious. Okay, thank you guys very much for your support. It helps me do what I love to do, which is this. So, questions, comments, whatever. That's a good answer. I'm going to go ahead and leave those in there. Appreciate that is doable. I think most people probably watching this could think of various ways, at least maybe not the most efficient way, but a way. What is going on, everybody? Welcome to part 11 of our Python 3 Basics tutorial series, where we have been learning to build a game of tic-tac-toe to pretty much just learn the basics of Python while actually doing something of interest. So where we left off, we were determining the horizontal row of winners, and now we want to just do the vertical row next, or vertical win, basically. So it would really be column. Anyways, let's go ahead and get into it. So what I'm going to do is actually, I'm going to comment out this section because the only code I want right now is just for vertical win. Later we'll combine all of the win types of codes into the same function, but for simplicity we're just going to do this. So here we have at least a game map. It didn't look very fair for player number 1, but we have a game map where player 2 clearly won vertically. So how could we determine that player 2 has won, or that somebody has won? Well, basically it would have to be everything in each row, everything with the same index would have to be the same number. So for example, for row in game, if we print next, or vertical win, basically, so it would really be column. Anyways, let's go ahead and get into it. So what I'm going to do is actually, I'm going to comment out this section because the only code I want right now is just for vertical win. Later we'll combine all of the win types of codes into the same function, but for simplicity we're just going to do this. So here we have at least a game map. It didn't look very fair for player number 1, but we have a game map where player 2 clearly won vertically. So how could we determine that player 2 has won, or that somebody has won? Well, basically it would have to be everything in each row, everything with the same index would have to be the same number. So for example, for row in game, if we print row 0 and we run that, we can see it iterates over all the rows, prints the 0th, so like the first element in each row, you see 222, right? And then you could have some sort of check here that's just going to be like a list. And because, like, remember, you have a little check column or check functionality here that determines whether or not someone has won. So we actually could use this exact same logic. So in fact, I'm going to copy it because I'm about to use it. And let's append row 0 to check. So a list, unlike a tuple, a list you can continue building. So to add a value to the end of a list, we can use append. So you can say check.append, and then we're going to append what? We're going to just append the value that is row 0. So then, whoops, I just wanted to comment that out. Then after we've done that, we could check. And we'll just tab this over. And instead of being row count, we're going to do check. So if check.count, check 0, and then check, and then check. And in fact, let me full screen this. I don't know why that was so small. Print winner. So now if we run that, we get winner. And then if we were to change this, hopefully back to a 1, we would see, okay, there's no winner. Great. So obviously that's great. But we've, hard-coded the check for row 0. So how could we go about checking all of them? Well, of course, we could do this, this little snippet here. And by snippet, I mean not a snippet. And actually all the way up to here, and do it 4 times, or 3 times rather, for the 0th index, the 1st and the 2nd index. But obviously, as I've said before, that's really not ideal. We want this code to remain dynamic as possible. So, and yes, I am aware that, there's 2 major things. One is the print of the 0, 1, 2 at the top of our game map that we've worked on before is not dynamic. We'll fix it, don't worry. And the game itself is not really changeable easily, but again, we'll fix it, don't worry. Anyways, we want to keep it as dynamic as possible. So, what could we do? Well, we could, I think I'm going to leave this here I guess check can stay. But basically, we would say, you know, we would need some number of columns. You could say 0, 1, and 2. Oops, 0, 1, 2, and then iterate. You know, for call in columns, and then run this, and then it would be row call, and then the rest stays the same. So again, run it winner, and then if we changed this, and then we did, I don't know, like this. Now, player 1 actually got an opportunity to play this time. Player 1 won, and we could comment this one out. Okay, no winner. Cool. So this logic clearly is working, but again, we've got this is being hard coded in, and we don't want that. So what could we do? Well, this is, you know, it's 3 elements, and it's just it starts from 0 and increments by 1 per each what? Well, per each column that we have, and also since the game is square, you could say per row that we have as well. So if we were to get, say, the len, which is a built-in function for Python, len of game, the answer to that is equal to 3. Also, we could just have a counter. Like, you could literally for call, and you could say for call in column. Rather than that, you could say for call in like, I'm trying to think of a really good way to get around it. But columns, basically, we could just say columns is, like if you just wanted to iterate 0, 1, 2, probably the best way is with a range. So again, range isn't something that we've talked about, but it's a built-in function in Python. So let me do built-in Python functions. Really? Built-in Python functions? 3.7 maybe? I'm surprised that wasn't like the top result. I must have typed it different than normal. Anyway, we can come down to range, and we can actually see that range, is it going to explain range? Huh. Anyway, okay, yeah, it does. Rather than being a function, range is actually an immutable sequence type, so it's actually not a function, but we treat it like a function, so it's okay. It's included in the built-in functions because we treat it like one, but in the back end, it's actually not a function. It's much more efficient. And the reason why you'd want that is, in theory, you could do, range of like a huge number, and that won't blow your memory. But if you were to do something to convert it to a list, for example, and make that a list of that size, that will absolutely blow your memory. So let me open up the command window real quick, and let's run pi-3.37. I'm so used to typing 3.6 there. Okay. And let's just say x equals range 3, and then like for I in x print I, you get 0, 1, 2. Okay, so it just iterates over that, and it's not quite a list. It's much more efficient than a list. And we'll see later that there's other operations that we can do on this that are similar operations to what we could do to a list as well. So anyways, that's how I think we should go about it, where basically this number 3 is just the len of the game. So what we'll do is we'll come over here, and so rather than being for call in columns, what we'll say is for call in, and then we'll just do range len game. And then we can get rid of this silly columns, run it again. Okay, no winner. Let's add a winner here. Let's do this. Run it. Okay, we've got a winner, and then we can change that and go maybe do this one over here. Winner, cool. Nobody should win. Cool, nobody won. Okay, so I think that probably the next thing that we want to do is, I think in the next video we'll do hopefully we can do both of the diagonals. I don't really think there's going to be, I want to stuff that in this video. Anyways, so this will be our methodology for detecting vertical winds. And this should work, at least from the, oops, I didn't mean to click on that. This should work for any size game board. It's just going to run through all of the rows at those specific indexes. And if there's a winner, cool, we print winner. And later we'll print winner to be a little more dynamic, say who won, how did they win, and all that. So we will get to stuff like that. But for now, I think I'll stop it here, and in the next tutorial, we are going to do the diagonals, which arguably is maybe the hardest, but shouldn't be too bad. So anyways, that's all for now. If you've got questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I will see you in the next video. What's going on? What is going on, everybody? Well, we could actually an immutable you could do to it rather than being for call and column. I think there's gonna be, I want to stuff that in this video. Anyways, so this will be our methodology. What is going on, everybody? You can throw in a second set of ads. What's going on, everybody? Complaining that the tutorials were like too short. Normally, what is going on, everybody? Len game. And then we We can get rid of this silly columns, run it again. Okay, no winner. Let's add a winner here. Let's do this. Run it. Okay, we've got a winner, and then we can change that and go maybe to the view. Apology, it's just going to they win and all that. So we will get to stuff like that. But for now, I think I'll stop it here, and in the next tutorial, we are going to do the diagonals, which arguably is